All right, there we go. Well, I'm on the old laptop because I forgot to email Cobb and have them take this laptop off the account, and so I can add the new one. And I don't have time to do that and wait for it today. So this is an 04 STI. I probably should put that in the title. It's an 04 STI, and it's got a bunch of stuff. Built motor. I don't remember what cams are in it. It's a little low on RPM right now. I need to see if that's the target or if. I mean, I just put a 4-bar in it and haven't tuned it for the 4-bar. I put the base calibration on it, but that's it. But even then, when you do that, there's still always just a little bit that it's off. So. Yeah, idle's definitely lower than I want to be. Currently doing my logging parameters. I want to talk about electrical theory today. I want to talk about how it applies to tuning and how it applies to burn speed. Now, that one you're probably going to be like, wait, what? How does electrical theory apply to burn speed? And honestly, that's something that just kind of I associated this morning when I was in the shower. And I'll explain why here in a second. Let me just get this thing up and running. Make sure it's working. This thing must have solid engine mounts in it or something. Because it is just old, just like a tractor in here. Everything vibrates. I think I'm going to increase the amount of fuel at idle, change the target to be a tiny bit richer. When you have bigger injectors, you often need to do that because, I mean, you can technically spend a lot of time going through the tune and, oh yeah, this is still the factory leaner than stoic target. You can spend a lot of time going through the tune and trying to find exactly which cylinder is exactly how much leaner or richer than the other ones and all of that. And without the proper instrumentation, and trust me, we do not have the proper instrumentation here. You know, I don't have in-cylinder or per-cylinder AFRs or that kind of stuff. But without that, it is hard to do, let me tell you. So, I'm going to just add a little bit of fuel to idle, and that'll help alleviate some of those conditions. Okay. Alright, I got one person so far in here. Hi, one person. Hope you are doing well. Alright, let's see. So I've got a 12% fuel trim at idle. Now some of that I believe is going to be the change in map sensor, and some of that could be the fact that now it has 2 fuel pumps. Differential fuel pressure is a smidge higher than it was before, but only a tiny bit. And my VE at idle. Sorry for clearing my throat. I apparently have a slight reaction to what I ate for lunch. So my VE is showing, I have 57, 58 for VE, but I'm showing 12% too much fuel. And 57 is definitely not 12% too high for one of these cars at idle, so I don't think it's that. This has got 13. Fucking program crashed before I saved my changes. Dude, fuck you. God damn it. Of course the fucking program crashed. And of course, it's on a different ECU and different map. I reopen it because it didn't save anything. Well, that's the Cobb software life for you. Anyway, so I want to talk about burn speed. That's been a common subject right now, like with Paul from Injection Dynamics talking about it and how pistons affect it. And it's been a common topic with a few things, actually. And so I want to talk about it because very few people, it seems, totally understand or even understand burn speed. And I think it's important to understand what things are affected by it and what effect those same things have on ignition. And I think that's where Paul was going in some of his stuff. He didn't say we're going to talk about ignition, but he brought up how much plug gap it takes to get rid of misfires. And I found him saying that kind of funny because I feel like he was baiting people with it, honestly. Maybe not. Maybe he genuinely meant what he said when he said, I want to learn something and think about something. You know, tell me what engine, what you got to do, what air fuel, what boost, and all that stuff, and then how small of a gap you got to run to get rid of misfires. And I felt like that was a setup. It felt like him saying, and how small of a gap do you got to run to get rid of misfires? It just felt like a setup to me. And I know that, you know, you do often have to shrink the gap when you go with a lot more stuff in the cylinder. And that's what I want to talk about is I want to talk about why that is and what things affect it. And and then I eventually want to do a video about it. I want to do a video where I explain it. But what I really want to do is I want to get to a point where I can do little animations and shit. But as of present, I don't have that technology. Whether it's just a program I need to download or whether I need to spend time taking stills and creating videos, which I think would probably be torture. I just don't have... I'm going to raise this idle to 850 because this vibration is shitty with these motor mounts. Yuck. This is bad. Anyways. So let's talk about that a little bit. First off, burn speed is so misunderstood that some people think that ethanol burns slower. That's how little people understand it. Somebody wrote at one time that the burn speed of a fuel was, what was it? Gasoline. It was like 18 ms, and ethanol was 22 ms. And so someone was like, "Oh, that's milliseconds." And 22 milliseconds is more, that means therefore it's slower, is what somebody thought. Well, they didn't realize that the units on that picture that the person posted were incorrect. It should have been m/s because it was meters per second. Because speed is velocity, and meters per second is velocity, and milliseconds is not fucking velocity. So that was a little doozy that I really enjoyed. And unfortunately, that little doozy increases the amount of people who don't understand burn speed, right? I mean, what is burn speed? Burn speed is the speed in distance per second that the flame front will travel in the cylinder. So you start at your center point of combustion, which is often called the flame kernel, or fuel kernel. It is the central point of combustion is where the spark plug ignites the fuel that is around it. Oh, damn it. Okay. Now this flame kernel how it behaves depends on a lot of things, or how it even comes into existence, really. So how do you ignite the fuel? That's the question. What does the spark plug do to ignite the fuel? How does that actually work, right? People just go, oh, well, just makes it start to burn, right? But there's actually, obviously, there's more to it than that. It's not just, I'm not lighting the match. And if I was lighting a match, that still starts a reaction of some sort and does it in a certain way. And that's what's important to understand, is how this reaction is based in physics, like what happens in this reaction. So first off, what does a spark plug do? Well, a spark plug is merely a means of taking the high energy from the ignition coil and ionizing a small portion of air or fuel, but usually air, in between two electrodes. If I'm going to generate a spark, that spark is the ionization of the atoms in between the electrodes. The potential difference between those two electrodes is so high that one side will strip electrons off of the atoms in between those 2 points, and then that movement of electrons creates current flow. Okay, now, in order to do that, you have to have enough electricity, or enough energy, enough spark energy, and we rate ignition coils in millijoules, have to have enough energy, make it to the plug, to ionize the molecules between those two electrodes. And that amount changes. Air, for example, is a very good insulator. Air is not a good conductor. It takes a lot of potential to ionize air. It's just a stable molecule. Well, all the molecules in it are relatively stable, I should say, because obviously air has lots of molecules. We've got nitrogen, we've got oxygen, we've got, some argon in there sometimes. We've got, CO2. There's carbon monoxide floating around, especially in there. There's going to be a little bit of that floating around. There's going to be, radon, with temperature inversion. We get radon temperature inversions. Like, there's all kinds of stuff floating around in our air, what's in there. But largely, when we talk about the air charge, we're talking about just the hydrogen, the nitrogen, and the oxygen. Usually, that's what we're talking about. So, we say 19-ish% oxygen, the rest nitrogen, with a smattering of other stuff in there. Those molecules are relatively stable. They are not... sorry, I'm looking at something here, trying to figure out why this thing doesn't rev up a lot when you start it. I got lots of idle air on it. But it just doesn't seem to want to go up. It starts, but kind of like, doesn't really pick up right after you start it. So I feel like I got a lot of air in there. Like, it should really pick up a lot more than it is. Yeah, there's a lot in there. Anyway, so I say stable. Now, we know that oxygen is very reactive, right? It's a very reactive element. So I'm not ignoring the fact that oxygen is in there, and oxygen does things, right? Oxygen gets down with stuff. It reacts with most things in some way or another. That's how you get rust, right? You get rust, you get... sorry, I'm trying to redo my freaking logging parameters because that didn't save either when my program crashed a second ago. Forgive me for being preoccupied here as I attempt to multitask, but has penis, cannot multitask is kind of, there it is, ethanol final. Idle speed target, I want that one, so I figure out what the hell's going on. Why she's not flashing up a little bit when I start it. I'm going to want some duty cycle, definitely intake temperature, definitely absolute pressure. Okay, so the reason I bring all this up is because it's really, I'm working on what I'm calling my theory of everything. And one of those things is that in most of the world, almost everything is one or two equations. For example, if I want to find the influence of anything into a circuit or a system, I should say, the equation is almost the same. It's almost the exact same. It's just a different unit. And the reason for that is that this concentration equation, for example, is the amount of something, the percentage of it, or the amount of it added to a system, and then what exists, and then the average of those, to get the final, is really simple. So in the case of a concentration, it would be concentration initial, volume initial, plus concentration added times volume added equals concentration volume or final times volume final. And that equation can be it's modular, I should say, right? Like I can do added 1, I can do added 2, I can do added 3, I can do added 4. I could put 6 things I'm adding into this system, and it'll tell me what the final concentration is on those things. So ethanol, for example, when I go to fill my fuel tank with ethanol, say I knew that I had 5 gallons of 10%, and I wanted to put 5 gallons of E85 in it, and I know that the E85 is actually 85%, all I would do is 5 times 10 is 50, 5 times 85 is something, my brain's not working, was that 420, 425 maybe, and then you add those together, you get 495 or 475, and then you divide that by 10, and so you get 47.5%. So something like that, I don't know. But that's the way that equation works. Now that equation is the same for when I'm doing a weight and balance on an airplane. It's the weight that I'm putting on the airplane. It's the distance from the center. Some people do it from the center of gravity, some people do it from the nose. Depends on how it's done, but from the center of gravity, for example. So the center of gravity of the airplane is at this mark here. I'm adding 20 pounds 2 feet from it. I'm adding 10 pounds 4 feet from it, and I got to find out how much that affects center of gravity. And that is the same thing. It's the weight times the distance, plus the weight times the distance, divided by the total distances and all that. So it's the exact same equation. Actually, not when you divide by the weights to get the total distance where the center of gravity is, the new center of gravity. But that's the same equation. It's just the value times an influence, whether that influence is in gallons, the value is 85 octane or ethanol, or god damn it, 85% ethanol. The influence is 5 gallons, or in the case of like the weight and balance, the value is 10 pounds. The influence is this ratio, this arm length, is the distance. This equation works for stressing members in a static system like trusses. It works for trusses, the same kind of thing. It's the weight times the arm divided by all the weights to give you a distance, or if you're going reversing the equation, to find out what the limit is, and you'll find out how much weight you can put somewhere, then you divide out the distances, right? But it's the same thing. It's the same thing. It's the value, it's the potential, I don't know what, the concentration, and then the influence, how much of it is actually going in there. And it's the same thing. It's the weight. Torque is like that, right? I'm putting so much pressure on a lever arm, so I got 10 pounds times 2 feet. It's the same deal. So if I wanted to do a seesaw, which is, again, like center of gravity on an airplane, I do the same thing. I could have 10 pounds at 2 feet, 20 pounds at 1 foot, right? And my center of gravity, I got this one be -1, this would be +2 as far as the distance is concerned, and they end up zeroing out, and the item would be in balance. So, but that same equation works for freaking almost everything. It's pretty crazy. And a lot of people don't put those little equations together. So anyways, the point of this is that part of this discussion is part of my theory of everything that I'm trying to put together. All right, so I need more idle air. This thing just is not, it's not flaring. I want to flare more when I start the car. Let's do this. Let's do that. That should flare a little more. Okay, let's go back to let's save that. And then let's bring up my logger. Now, I didn't change anything in my logger, so my airfield trims are still going to be 12% or whatever. I didn't change anything in my VE table or my injector scale or my latency or any of that. And honestly, I don't know if this car has IDX2s or regulars on here. Apparently, I tuned it as if it had regular 13s in it, the X's, not the X2s. But I'm kind of wondering, with all of this fuel trim here at idle, if that's correct. I'm going to pull out my Injector Dynamics spreadsheet. Injector Dynamics is always nice enough to provide you with plug-and-play data for your engine management system. It's not always accurate, and in this regard, it's not always formatted correctly because manufacturers change their methods, I should say. They change their software, so they might have different axes, might have different whatever. So I'm looking at the X2 data, and at this same pulse width here, it's pulling a lot more than I'm pulling right now with this data. So my low pulse width stuff might be wrong. I might actually have X2s in here, and it's tuned for regulars because it seems like it's really rich right now. So I'm going to try that. I'm going to put this, since that's one of the worst parts about Injector Dynamics injectors. It's not Injector Dynamics the problem. It's all the suppliers that get the new injectors, put them on the shelf, and they put them on the shelf in front of the old ones, and they don't bring the old ones to the front, and then you're stuck getting injectors one day that are X2s, one day that are X's, one day that are who knows what, and it's kind of frustrating. I wish there was a way that ID could hold these people accountable a little more and force them to give us the right shit, because yeah, it's annoying. Okay, now this one has a much higher latency at idle, or not idle, at 14 volts, not much higher. It's 0.1 milliseconds, but that's going to make it roll really rich right this second until these new low IPW settings get flashed, which is going to happen here in a second. I'm going to flash these again. So yeah, electrons are crazy, right? Electrons are responsible for so much. And as I was talking about with the ionization of the air in between the 2 points of electrodes in the spark plug, you got to have enough potential difference to basically force that ionization. And if you pack more molecules in between those two electrodes, there are more molecules that I got to strip electrons off of. So if I raise the boost, now the density of the material in that cylinder between the electrodes is much higher. Now I have more non-conductive molecules between the electrodes of my spark plug. And so if I don't have enough spark energy, is this flashing? Yes, it is. I don't have enough spark energy via the coil packs to strip those electrons off and make current flow through the air and insulators effectively, it won't. It'll misfire. So an option is to then gap down my plugs and put those electrodes closer together so that the amount of molecules that can fit between those goes down. So now if I have less molecules in that void, then it takes less energy to jump that gap, to strip the electrons off, because there's less molecules to pull electrons off of. And I think that's important. And that's important for a few reasons, because that spark event initiates the flame kernel, the initial point in the cylinder where combustion occurs, and that affects burn speed. So at first you're going to be like, wait, what? Yeah, so what I'm saying to you is that my spark plug gap affects burn speed. And some people would say there's no effing way, but what I'm telling you is that if I have a wider gap and I have more molecules in between those 2 points, that means I have more molecules that I have stripped electrons off of. I have more molecules in there that are getting energy from that spark event. And I have more molecules that are starting to burn at the spark event. And if I have more molecules that are starting to burn at the spark event, then I've already got a head start on my combustion. If you think about those exponential growth curves where 1 turns into 2, 2 turns into 4, 4 turns into 8, right? 8 turns into 16. Well, each of those steps takes time. If I start at 16, well, I'm going 16, 32, 64, right? Like I'm already forward on that curve. So gap affects burn speed. Now, I'm trying to figure out if that's the right way of saying that. Does it affect burn speed or does it affect burn time? Because the exponential growth is still the same rate I just started earlier, or further in the curve up there. So now what we're talking about is now we're looking at burn speed in units of time and not just in meters per second, because the flame front speed is still going to be around whatever meters per second the flame front speed of ethanol is going to be, but my initial point is bigger and the distance I have to travel is less. And that means my cylinder pressure is going to rise more quickly than it would if I had the narrower gap. That was really annoying. It still does not flare. I've got this thing adding a ton of throttle. I've got like 5% at startup, and it's still not flaring up. I don't understand what the hell's going on. That is really annoying. I mean, I got this thing at 5% freaking throttle, and it's not flaring on me. I'm not getting any rise. MK, hello MK. How much better are the X2s? I don't know the answer to that. I know the X2s, I believe they flow a tiny bit more. They have very different short pulse width tables. The X1 short pulse width table, I think, is better, honestly. It's more linear, whereas the X2s go like negative 45%. Like they got big negative trend. Now that being said, I'm trying to recall if factory injectors were negative or positive. A lot of injectors a long time ago used to be big positive trends. And so if you put an X2 on like a 16-bit ECU, you will have more problems than if you put an X1 on a 16-bit ECU. Just one of those things. So, because the 16-bit ECU is going to be adding fuel, and the X2s need you to pull 45% or whatever at that point, and they're not getting that. I don't think it's 45%, actually. It's, what is it, 45 milliseconds? Oh, no, that can't be right. Is it percent? Yeah, it's percent. Yeah, 40%. So yeah, it's kind of hard to say which one's better. They're both awesome. They both work great. It just depends on what engine management system you have. And if it's a modern system, you know, a 32-bit ECU that's 904, if it's a standalone, it's not going to matter. It's not going to matter if it's an X1 or X2. They're both great. You're going to get extra performance out of each of them. It just sucks for the tuner who has to try and figure out what's in the car because the customer says, oh, I got 1300s in it. Great. Which ones? Are they the ones that flow 1315 or the ones that flow 1350? Is it a 0.93 or a 1.03 millisecond latency at 14 volts? Is it negative 45% or negative 17% at 380 or 400 milliseconds of pulse width? Right? So now it becomes an issue where you're just like, the fuck do I do? You got to take it apart, or you got to do, I just did an experiment to see which one seems to work better. And right now it looks like the X2 profile is working better. So the trims are not as large. Oh man, that is louder in here. I thought it would be. No back seat makes a difference, I guess. The trims are not as large, so that's good. All right, so I'm gonna set the tach on the dyno. We gotta go 60 miles an hour. I'm gonna set the tach 4450, and that says 4390 on the ECU. So 4450 on the tach. Now right now it feels really smooth. Ooh, tipping's aggressive. Tipping's too much. I tipped that in and it went negative 25 and it hesitated on me. So I got to pull a smidge out of the tip in. Let's see. Yeah, that's a little aggressive. So let me see. I'm not real timed. God damn it. Every time I go real time, this thing crashes for some reason. It's right there. I might have to tweak wall wetting for that, if that's doing it right there with only 0.2 milliseconds on it. Yeah, that's too much. A lot, so I gotta do some wall wetting adjustments, I think, because that just doesn't want to come down at all. And I already have done wall wetting adjustments. So I guess that means my SD, my volumetric efficiency table, is too high right there. Let's see, what do I got? That's actually laggy as shit. Oh, it's a big jump right there, actually. Let me clear that spot out a little bit and see how it goes. Yeah, that's that sucks. I hate the 04s. They're just barely above a 16-bit ECU. I gotta pee. I'm not a fan of that. I'm not a fan of that. go to my speed density fuel smoothing. See what that's set at. It's really high. Oh no, it's not. Okay. Keep working on that. In the meantime, let's do a little pull because I know the boost works. I did pump gas on this before, but now I got a 4-bar map sensor, so I just want to make sure that it's good now. It should boost fine, should have no issues. Like I said, this thing was tuned once already. That's a previous car. Look at that one. That's a car I did the other day. Looks real nice, doesn't it? That car is an STI, but it didn't have closed DAC and stuff, so you can see I kept the torque soft in the mid-range there, but man, it drives great. Different car though. I got to wee, I got to go to wee. Alright. Let's see what happens. So yeah, one knock event there. I let off. It was Rich's Bizzles and the boost went to 28. So I would say that it boost control system is not working correctly. Oh shit. Alright. Definitely not working correctly. And it's doing that at 28%. What the fuck? What the fuck? It's doing it at 5%. No horn. So at 5% wastegate duty, we've got 30 pounds of boost. Well, that's not going to fucking work, is it? God damn it. Somebody fucked something up when they were doing their work under the hood. Target is 20. It's not fucking 30. Alright. Well, coincidentally, I let out at the same time the overboost cut was happening, I think. Or it misfired from blowing out spark, which it could have done. Absolutely. Look at that. I got it here to 5. It had a huge turbo on it before. Oh yeah, they changed the turbo. Yeah, I should have fucking. That's right, they changed the turbo. But it definitely doesn't have a 30-pound spring in it. So we're gonna go ahead and just zero that the rest of the way because obviously it doesn't freaking matter. And we're gonna hit this, and then I'm gonna go tell somebody. Beep beep. Honk honk. This car has no horn. Alright, I'm gonna take a leak and tell them what's up. Give me a second. Then I will talk to you more about stuff. Yeah, usually.
Like, I don't make the rules, I just don't follow them.
God damn it. Yeah, so the universal sign here is that I honk the horn and they come to help me out. Especially when it's their car. So this car though, the horn doesn't work. So that's why I yelled beep beep. Yeah. So yeah, well the tuning's done for a while. I'm gonna look at this tip-in stuff and see if I can figure something else out because it's just well idle trims are perfect now. 1%. That's freaking great. That's way better than it was before. And that makes more sense because the VE at idle is usually 55 to 58% on stock cams, sometimes as much as 60 on stock cams, and that's what I had. And the fact that it was 12% too much tells you no, something's wrong. So I changed the injector data, and bam, fuel trims are now 0.0 right now. So that is good news there. I still have to figure out this tip-in. Now it's weird because I have way less tip-in than I usually do on this. Way less. I have low VE, I have less tip-in, and I have less wall wetting, and it still goes 20% correction when I tip in. That is perplexing. That is perplexing. I gotta figure out what the hell's going on with that. I have way less tip in than I usually. That is good news. Let's check my fuel pressure differential. You hooked up part of the boost control lines. Alright, let's see. What else can it be? Why am I getting so much fuel? Now this car definitely has 13s in it, right? Not 17s? Alright.
Did you ever ask Paul?
About what? I'm not going to ask Paul for free injectors.
Huh?
I'm not going to ask Paul for free injectors.
No, it's not free.
Oh, then
just
what?
to test. I mean, he can have them back, like whatever. Like, I just would like to know what they do.
Oh.
See if they're cool.
Well, they're his injectors. They're cool, and he knows it. So.
Huh?
Said they're his injectors, and they're cool, and I'm sure he knows it.
Well, I know they're cool, but see if they fucking idle on pump gas. See if we can take a car that doesn't idle on pump gas and then have it idle on pump gas.
Yeah.
It'd be great advertisement for him.
Well, I had them idle on pump gas on the 22s, with the new 26s, and that's crazy.
Yeah.
That blows me
the
away.
2000s fucking straight up don't work.
No, that doesn't work. And the 17s barely work.
Yeah.
But he redid those 1650s for that reason, so.
Yeah, I think it would be a good thing to do.
Yeah, but he doesn't need me, you know? That's the thing. As much as I would love to say that companies need me, you know, some do, you know, like this one, but Inject Dynamics does not need me. They're way popular. They have tons of great tuners that use their product. They don't need me for shit.
I don't think advertisement's bad.
No, I know, but like I'm streaming right now, and I have 4 people. So, you know, I'm not the pinnacle of advertising either. Yeah, everybody's got more than me. I know. Because my stuff's too educational.
Yeah, no, that's for sure.
So, I'm talking about spark plug gap and how it affects burn speed. And electrons, and what electrons do, and all that stuff, so. It's definitely not the material for everybody. And I understand that. And I appreciate you being here. For those that are here. Okay. Yeah, I'm just not seeing anything. Let's compare this to stock. See what other wall waiting tables I changed since stock. Just that one. Okay, so there's only that one that I adjusted, so I can change more. I just don't like to change them a bunch because the engine isn't that different. You know, like, what cams are in this? It's got B's, right? And that's somewhat different, but it ain't that much different. Yeah, which is a great cam. I like it. I'm just trying to figure out why the tip-in is so much.
Is so what?
So much tip-in.
There's so much tip-in?
Yeah, when I tip in, it goes stupid rich. And I'm trying to figure out why it gets so rich.
I was going to ask you why this one felt so good. Like, it doesn't feel lazy. It feels like really, like, snappy.
Yeah, it's
like
actually not that snappy. Put it how it should be. So, I'm working on it right now.
Yeah, no.
Slowly.
I'm definitely interested to see. Because it's got a twin disc on it, so it's not like it has a nice flywheel or something.
Yeah. Oh, that part. Yeah, I heard you revving the shit out of it in the parking lot. Sound like you were at a Honda meet trying to back into a spot.
Huh?
Sound like you were at a Honda meet trying to back into a spot.
It's like you dying.
Ram, 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 ram. Yep.
So you don't stall it like a fucking turd.
Right. That's the reason. That's how you break a clutch in. Now, do you gotta tap that one?
Nope.
There's already a bung in there?
Yep.
Oh, okay. Well, that's good.
Yep. So she's done. I'll plug your fans back in.
Thank you.
And you should, big question mark, have boost control.
Awesome.
I hope you have boost control.
I also hope.
This thing also has a turbo shard on it.
Turbocharged what?
Turbo shard wastegate.
Oh, you're killing me, Smalls.
So I'm interested to see how that goes.
Yeah. I mean, so far I went to 30.
Yeah, but did it fucking straight up, straight down, straight up, straight down, straight up again?
Oh,
All the way
right.
to 30?
Yeah, I don't know. I didn't do that yet.
No. Well, the boost control wasn't hooked up, so it was
Right.
just
Yeah.
pressure. Which I'm sure if you just used them as like spring pressure gates, they'd probably work just fine.
Well, yeah, they
Swap springs to your desired boost.
they work good at like one specific boost pressure.
Yeah.
You tune them for that boost pressure and they work better.
I see.
Yeah.
Just not enough priority.
There's
not
not
enough.
resolution or control. Yeah, it's just so finite.
Well, the diaphragm's really small compared to the piston size,
Right. Yeah.
so it has not very much leverage.
Yeah. Less authority.
Yeah, less authority. That's what I was thinking.
Yep.
Priority, no authority. All right, have fun.
Thank you. Let's flash my changes. Initializing vehicle for communications. We only advertise your dog. Hey, I appreciate it. Would definitely appreciate it. Tip is one thing I've always had trouble tuning. How do we know when it's right? Okay. How do you know when it's right? Well, perfect tipping, as in completely perfect, no screw ups and everything, is when AFR does not change during a tip-in event. So if you tip in, when you tip in, if AFR is flat and you let back off and AFR is still flat, that's perfect tipping. If you get that, it's right. Now, does that happen on a Subaru ECU? Never. Absolutely never. Not at all. This ECU never has that kind of tip-in. Even stock, it doesn't have that. So what you are looking for is two main things. One of them is no gigantic AFR transients, and preferably no transients towards the lean position, because lean tip-in often misfires, and you can feel the lean tip-in misfire easily. That's very easy to feel, and it creates a car that goes when you give it throttle, and nobody wants that. Rich tip-in just creates a car that's a little laggy. It doesn't go, it just doesn't accelerate as fast. It's just kind of, and it comes up. Or rev, it just kind of comes up. Whereas like a lean one will clearly hesitate and then pick up. So you don't want either of those transients on either side to be large. Ideally, like I said, your air fuel corrections on a tip-in event will be small. On the factory ECU, if you can keep it under 12, you're doing good. That's really hard to do in the factory ECU because it doesn't do it stock. So, I mean, if you can do that on the factory ECU with an aftermarket injector, then you're doing really good. But with other ECUs, there's no reason you can't get it to be really good, unless it's a Haltech, then you're screwed. But if it's like a Link or an M-Tron, you can get it to be really good. You can definitely do it. So the biggest thing is that you want as little AFR transient during the event, because all tip-in is doing is compensating for wall wetting, sensor lag. I guess it's wall wetting and sensor lag. That's really what it's compensating for. It's using the throttle plate movement to initiate an enrichment, because at that point the air is already starting to get into the engine, and the map sensor is going to be laggy because it's got smoothing on it. Otherwise your map sensor would be doing this, right? So you have sensor lag, not just in measurement to reporting time, but in smoothing and stuff in the ECU. So you have to feed it extra pulse because you're going to have that. You're going to tip in, air's going to come in. The fuel that's right at the saturation point, at the increase in pressure, is going to plate out into the puddle, and you're going to get less of it into your cylinder. Fuel that's well below the saturation point, when the pressure goes up, is not going to puddle as bad. But when the stuff that's right there, that's right at that saturation point, which is a good portion of it, a lot of it's going to go to the puddle. Or just become saturated large droplets, and large droplets don't atomize well and they don't burn well, which will make the car boggy as well. It'll make it lean, even though technically you could have too much fuel in the cylinder. It won't be available for combustion as available for combustion because it isn't mixed very well. It's a big glob, and big globs burn slow because a big glob has to burn from the outside in, and I got to have oxygen get into there. Well, if I have this glob, we'll say this round circle, all these molecules of fuel, and I got air around it, and I start to burn, well, it starts to burn on the outside, but then what happens is the byproducts of the combustion displace the oxygen that you need for the inner ones, for the molecules on the side. So you shield. There's another term for that, actually. What's the actual term for that? I forget. But it's basically you're shielding the inner molecules from reacting because the outside has displaced the oxygen that the inside would react with because you got post-combustion products in there. So, what don't you like about Turbo Shart Smart, and which wastegate you prefer? I call it Turbo Shart because it sucks. I can't stand their wastegates. They have terrible control. They have terrible diaphragm materials. They fail all the time. Bunch of stuff. I'm going to answer this, but I think it's probably spam. Hello. Hello. I am robot. Alright. Spam. Yeah, Turbo Smart wastegates blow. They are such low quality. They don't have good resolution. They suck. I rarely have a Turbo Smart wastegated car have good boost control. You find that you can make them control a boost level well, but the other boost levels you cannot. Get an occasional pop out the tail right now. My air fuels are 14.4, which is my target, so my trim is only 2%. But I'm getting a pop as if one of my cylinders is actually still a bit lean. My commanded fuel final is 17.7 because the evap is currently running, but it's obviously set up correctly because my trim is only 3 or 4%. There's that pop again. Yeah, I can't stand Turbo Smart race gates. I think it's the diaphragm material is poor. The spring material is terrible. The springs fail, or they just get soft. They change their pressure all the time. You know, like on really cheap, crappy suspensions, when someone puts springs on their car, like, oh, the spring's got to settle. The spring should not fucking settle. That is not how springs are supposed to work. Springs are not supposed to change their rate and their shape with use. That is not what they're supposed to do. But with low quality springs on cars and various coilover brands, especially Swift springs, for example, Swift springs are really bad. Swift springs are so bad, I think they're worse than a lot of the freaking just black powder coated Chinese ones that come out of China or whatever. Swift springs are way worse than those. Those things, they're not even shaped like springs after like a couple of uses. They're really bad. And I think maybe Turbo Smart has their springs made by Swift because they're garbage. They lose their pressure. The diaphragm material corrodes easy. It's not a big enough diaphragm for the gate size, so it doesn't have good authority like your lane talking about. It's just not a good valve. Obviously, they'd fight me on it, right? Because it's their product, but yeah, I can't stand their valves. Okay, so we're going to pull here. Hopefully the boost is something less than 30. Hey, look at that. Got lean up top, though. Top. That's actually kind of wonderful because I'm looking at the fuel pressure and it wasn't lean from fuel pressure. That means that the VE on this smaller turbo is somehow better than the old turbo, which is way bigger at this same level. That's crazy. That's crazy. That's great news, but that's crazy. Wow. Okay. Now, right there, you see it. You can see in the dynograph it went to 12.5 in boost. Luckily, the boost is only 16 pounds or so. Let me see what it was at. Absolute pressure, 32. So yeah, about 16 pounds-ish. So, now if this was a Link or an M-Tron, they would have kept the fuel flat. The fuel would have been fine. Luckily, there was no knock during that pull because the timing was so low. The timing was 12 degrees at 45 and 18 degrees at 7,000, so not a whole lot of timing on it. But yeah, if that was an M-Tron or a Link, it would have been flat fuel, and I would go into the log and look at the trim that it took to correct the fueling. Oh, someone's in my house. And then I would go to the VE map and fix it. All right, who the fuck are you? Why are you at my house? Well, that might be my neighbor. Probably there's another neighbor coming to bitch about the road. I'm not doing enough to take care of it for him. That's what usually happens. For some reason, since I'm the young guy in the neighborhood, they all expect me to fucking work on the road for them. It's really annoying. We have a private road, so, the young 47-year-old has to go and do all the fucking work on the road and shit. Sometimes I tell them just to get fucked. So, auto airflow target is 256. right, man, I'm really excited. I'm actually excited that the VE is so much higher right here in this range. That is great. I'm looking at the cam timing, see what the cam timing's at. But man, for it to be that much leaner than it was on the last turbo, that is great news. That is freaking great news. What power curve look like right there? Is it lean as mean action or what? What we got? Oh no, it's nice and controlled. Little tiny spike. A little higher power right there. Was a little leaner. Got a little cleaner burn. But yeah, look at that. Oh, man, I love this turbo. This is looking a little laggy. This is much laggier than this turbo usually is. So, man, it's a lot laggier. I actually need to... This turbo is usually full tilt 1,000 RPM before that. Alright, we'll have to adjust that some. I need to raise the speed of the start, though, too, because the way this dyno works, it's actually the biggest flaw of this dyno. The way it works is it loads the car, applies a base loading, and then tries to control the ramp rate from there. And so when the boost hits, or as the stuff starts coming up, then it doesn't have... It doesn't anticipate the load that the engine's going to make as the boost is coming in, so it doesn't control the ramp rate well enough. It's really weird. I find remarkably that somehow I don't hit a lot of different load cells. Often I hit a bunch of different load cells on the road than when I tune it. Somehow, with as weird as this thing is, I don't find myself hitting a bunch of different load cells on the dyno versus the road. I don't know how that's even possible because it does do such a different job controlling it. But I do also start the poles at various RPMs and hit different load cells in the tune, so maybe I'm just getting them all during the tune. I don't know. But anyways, yeah, so this is a little laggier, but with this dyno, if I start the pole 5 miles an hour or a few miles an hour later, like say 35, the boost will come in like 500 RPM earlier. But I'm going to review my cam timing and see if that's tracking like it's supposed to. Let's see. Okay, start the pole, cam timing. Oh, it's up there. It's 30 degrees. And it holds 30 for a while. That could be too much. It might be too much. That's a possibility. But the cam timing otherwise looks good. Let's check that tip in. Let's see how that goes. Let's see. Oh, that's a lot better. That was way better. It still hit 18 on that one right there. Still had hit. That one hit 20. So that's not good. Each time I pumped it, it got worse. Alright, so we'll check the duration. Applied counter reset. Huh. And that one's leaner. Alright, so apparently I'm feeding that puddle with this tip in. Yeah, see, that one's less. And that one's more. I say you see, you guys can't see it. I apologize. I'll just try and tell you about it. Still too much tip in. But it's too much tip in at the larger throttle movements, not at the small throttle movements. So I can try and change it. I'll make a huge change right now and see what happens. See if it falls on its face or what. Huge change. Still snappy, but it's a little more than I want it to be fuel-wise. If I take this down, this will be a huge change. It'll be too much, right? That's too much. It's not too much. What is going on? What is going on? Is this even working? I feel like the change I'm making isn't doing anything. Huh. Let's see. My tile has been good to me. Yeah, man. Tiles and Garrett's. The new Garrett rocks. I've had a lot of good time with the new tiles and the new Garretts. Both of them have been really good. I really appreciate them. I also don't like how expensive TurboSmart made their e-gates, because one, the construction of them is not very complex. I think they charge that much because they're the only one. But like, if you look internally at those things, it's kind of scary at how small and chintzy some of the stuff they have in there is. I don't like it. I would like to use more e-gates and that kind of stuff, but I am not going to pay $1,200 for a fucking wastegate that's so simple in design and cheap in components. Just no. To the other guy, my G4X has been amazing, just on remote tune from Dom. Yes, yeah, the G4 is really good. I mean, it depends on what car you have, but obviously Dustin's got the issue where the CAN bus stuff isn't right. But Link did just do a bunch of CAN stuff. They might have updated all the CAN stuff for your car, dude. So we should consider doing or you should do a firmware update on it, and see if the CAN stuff has been changed or if there's other CAN options in there now. Because Link did do a bunch of updates recently, which is great news, for us, obviously. But I would think about that, honestly. Okay, so let's go to that map. Look at that. So volumetric efficiency. I don't have it dropping that hard up there. I'm really surprised it went that lean. Fuel pressure was good though. Fuel pressure was beautiful. What are RPMs that showing at? 67. Okay. The cams are moving at 67. The intake cams are moving there. I know that. 67's up here. And we were at 32. Oh yeah, there's a 6% drop right there. Okay. No, it is dropping fast there. Well, let's add to that. Whoopsie, too much. Alright, so I added some fuel in there. It should be richer now. I'm probably too rich up top now, but I'd rather start too rich than too lean like I did already. Okay, and this fuel map only goes to 22 pounds, so that's not going to work. I need more than that. So this is actually going to lean the car out now when I do this. So before I do that, let me look at this one. I'm going to copy the 32 to 34 section, and then, because I'm changing the axes, and then I'm going to go and interpolate some stuff, and then put those axes, or boy, words are hard. Those values into this new spot, so that I can interpolate some stuff between here and where I pulled it out of. Alright, and that should be a little better. I like it. Alright. Happy with that. Let me check my phone real quick. I just got a thing. Delivery notification has been scheduled for tomorrow. Yep. Between 8:30 and 10:30. Fuck yes. Good. I'm excited for that. And all it is furniture. I'm excited for furniture. For those of you that have been to my house, I don't know if anybody in here has been to my house or not, I have a lot of whiskey. Unfortunately, I don't have a drinking problem, so I have a lot of whiskey. If I had a drinking problem, I wouldn't have any whiskey. Right? I have a lot of stuff of various brands, recommend it. Let me tell you, our turbo kit on a 2.3 liter with my cams spools this turbo way fucking faster than this 2.5 liter with just regular Kelford cams, which is a good cam, don't get me wrong, and some other aftermarket turbo kit that's not ours, intercooler kit that's not ours, a 2.5 liter and regular cams. This thing does not spool fast at all compared to how fast my cams and our turbo and intercooler kit spool turbos. It is remarkable, the difference in spool time. I'm going to have to do a comparison because not enough people believe me, I guess, but I'm trying to make this thing spool faster, and it is not. I mean, it barely came in quicker that time. Granted, I'm on 0% wastegate duty. Adding some duty will aid in the spool, but even then, it still does not spool. Does not spool like my cams do. And it's not even a comparison. So I'm rich here. Definitely too rich here. It's really good in this spool region. I like this. So what you're seeing here is I have this thing set up to be closed loop but target rich. So it's actually closed loop right here. That's why it's running a flat 12. You see how flat that 12 is? That 12 is two things. One, it's safe, and I like that. It's safe, and it assures that it stays there, and then it pops to open loop and then goes too rich right here, which will impact the spool some up in this area as it gets too rich. So I can, and I will, lean it out here, which will aid the spool. I'll add some wastegate duty cycle. That will aid the spool. But overall, this still is not a comparison. I'm really surprised by this. Honestly, I'm really surprised by that. I added a lot of fuel, and it did not bring it down as far as I thought it would. I wonder if I have issues with the downpipe or the exhaust and where the wideband is. I wonder if that's even accurate. Honestly, that makes me doubt the accuracy of it. I mean, it did come down, but it makes me feel like there's an exhaust leak somewhere sucking in air. And I hit like a resonance and it's in there. Unless it's fuel system resonance, which does exist. The older IAG rails, for example, with their original dampers that they put in there, they often did this exact same thing. Oh, I wonder what this has in it. I wonder what dampers are in it. Because fuel dampers that are just the regular ones that don't have a boost reference or whatever, they will do that. They'll do that exact thing. They will cause an issue where the fuel does exactly what it's doing right here, actually. Quite a bit rich and then quite a bit lean. What is this ratio here? 67, 47, and lean at 27. There might be something going on with that, actually. Let me see. Oh, we called again from the same place. Hello? Hello? You're live. On air. Hang up. Alright, let's see. Let me go back to these comments, make sure I catch up here. Saki Smith's reflash tuning is getting old. Yeah, rear flash tuning sucks balls, dude. First unit for defined tables you need. I'm ready for standalone on this car. Yeah, dude. So for the VA, they just released a G4X that actually works with the VA. The can isn't as good as the M-Tron. It doesn't have as many features, doesn't do as many cool things as the M-Tron does. You do have the beauty of it being fairly plug and play. You do got to buy a can Lambda, which is external, but works pretty good. but the feature set is limited, and the fuel model capability is less than the M-Tron. But for the dollar, you can't beat a G4X. You just can't. You can't beat it. For the money, it is by far the best aftermarket ECU for the money. You can't beat it. You just can't fucking beat it. And they run cars really well, and they're just complex enough that you learn a bunch, but they're simple enough that you can tune yourself, or at least learn to on it, if that's your thing. So it's straightforward, whereas like the M-Tron is not straightforward. So and then with the M-Tron, you got to ask a lot of questions because their help file isn't very good, and they don't tell you as much as you want to know about certain functions. Like, I don't know how this function works, and like, well, it makes boost happen. Like, oh, okay, but I want to know like how. They don't share enough of that with you, in my opinion, with the M-Tron stuff. So you really got to spend a lot of time with it to get good at it, and spend a lot of time trying to understand the philosophical and technical aspects of it. Whereas with the Link, it's more straightforward. This is timing, this is idle, this is whatever, right? So if it's your first standalone, you're going to tune it yourself, the G4X is an excellent idea. But if you're looking for a bunch of features, bunch of motorsports features, it's not as good. If you plan on running 8 injectors, it's not going to happen, and things like that aren't going to happen. But without a bunch of expansion modules and that kind of shit, and adding a bunch of wiring and all that. Whereas with the M-Tron, it can happen relatively easily. So yeah, that's up to you as how much you want to spend and all that. Both are great systems, and I will happily give you some guidance on either of them if you want. And if you buy them from me, I'll even get you running. So on tip and stuff, is map for load calc better than MAF? Yeah, pressure. So the speed at which MAF is measured depends greatly on the system. If you got a big front mount, sure, you have a big accumulator, in front of the throttle body before it even gets to the MAF. So yeah, if you're on a front mount, you're definitely going to see pressure before MAF. If it's on the top mount and in a stock type setup, the MAF is really quick. It's pretty fast, and the pressure's fast too. They're both pretty quick. But you don't get a choice, right? You don't get the choice of what the ECU uses for those. And really, I should clarify, it doesn't use either of those. Well, not either. That's a lie again. Let me clarify even more. So, tip-in is largely throttle-based, but there's also map delta-based tip-in. Factory ECU uses both. Link can use both if you enable the wall wetting functions and all of that. And a modeled fuel model and not just a regular traditional fuel model. M-Tron doesn't really do tip-in like everybody else does. It doesn't do anything delta map at all for tip-in. It's all throttle. They use what's called TMAF, which is even more responsive and helps take out that instrument lag, sensor lag. It doesn't mean wall wetting doesn't exist. It's just because the TMAF jumps so quick instead of it has like this transient period where it spikes and then settles to where it's supposed to be. That transient period dumps a bunch of fuel in the engine, and so therefore the sensor lag doesn't really matter on it. So the other part of tip-in is that tip-in is making up the difference between the lag, the sensor lag, and all of that. So sure, if you're on a MAF-based system and you have a big front mount and all of that, the MAF will lag more than it would the map. But you don't get the option of changing that with the factory ECU. And unfortunately, if you're trying to cover that much sensor lag, that's rough, man. Because that means you're really fudging it a lot. And that makes it just plain old difficult. So, hey, Mark. Good talk yesterday, by the way. Kind of surprised no other company has released an e-gate yet. The TurboSmart one is how many years old now? Matt, I agree with you fully, and I was thinking about it as I was saying it, thinking, why haven't I done it? But I'll tell you why. That shit's fucking expensive to make. Tooling up for that, the materials and all that stuff. If I was to make a batch of 100 of them, I would have to sell them at $1,000 each, because it would just cost me too much. Although I think even at a batch of 100 and some at 1,000 would probably be a better product. And then if I did a batch of 1,000, I could sell them at a lot less than they're selling them. The issue with that would be just having the capital for that. Like, I don't have that kind of capital. I don't have that kind of money. I can never do it. So, Dustin looking into the can thing. Good. Concerning head gaskets, do you have a favorite setup when doing a G30-770 build? I use the Athena gaskets, JE Pro Seals for most of my stuff. I have been trying to get something done with Cometic because I feel like I can make a good thing with Cometic, but I don't have anything available yet. Trying to finish practicing Fourier series and integrals. Ugh. I'm mad this stream notification just showed up. Oh, so you missed all my spark plug gap stuff. Sorry, Dino. Link, this is mostly a fun daily. I have a Miata on Mega Squirt, so not really new, but not a pro for sure. Yeah, you'll like the Link so much, you'll be like, I'm ditching the Mega Squirt. You'll want to get rid of the Mega Squirt. You'll like the Link so much. They have a cheap Link like that would run the Miata, and it's like the same cost or less than the equivalent Mega Squirt, and the features and the fuel model and everything else just blow it away. The resolution on the tables, everything is just so much better that you'll want to burn the Mega Squirt to the ground, smash it with a hammer. So, all right, let's see if Lane got my massage. He did not. All right, let the beep beep again. Beep beep again. So it's Lane again at 67 again. And 67, what is my VE there? 67, my VE is 101. My cams aren't moving. They're not moving that much. 5 degrees is not enough to create that much loading in VE. I wonder if this is a bigger turbine housing. Do they put the big housing on it? That could be. If they put the big housing on it, that'd make more sense. All right, so the rich spot, though. The rich spot is what, 47? So let's go to 47. 47, my VE is what? Oh, interesting. The ethanol had a little wiggle in there. 47 is still almost the same boost pressure, and the VE is 106. So it thinks the 106 is too much. Wow, that is really pushing that up. Okay. All right. Well, you know what? I like that. I'm happy with that. I'm fine with that. And I know I'm talking a lot to myself. I'm talking to you guys too, just to keep there being too much dead air while I go over all this crap in my head. So I want to talk some more about the whole electrons thing. I talked a little bit about that. And I would say we talk about it in the terms of capacitors. And if I talk about it in terms of capacitors, I think that will cross over to the other stuff I'm talking about and will start to make more sense to you as to why all the stuff I've been saying is what it is. So, anyone in the chat, what is, if I was to tell you what a capacitor did in just one sentence, what is the function of a capacitor? Anyone here tell me, what is the function of a capacitor? There's a nifty little catchphrase or saying that you can use to describe what a capacitor does, and you do the same thing for an inductor, which we'll say also here in a minute. So I want to know what is the function of a capacitor. And in the meantime, I'm going to flash my ECU here. Store energy, store electrical charge. Okay. It's funny, you're almost echoing what I said earlier. Dyno, and when I was talking about the spark plugs earlier, so you're kind of echoing and going where I was going with it as well. So we can talk more about it later here. If they're not discharged, yeah. Store energy, okay. I would say, okay, that's possible. But I would argue that I could, Will Morgan says store electrical charge, for example. I could take both plates of a capacitor and dump a bunch of a charge on both plates and have a ton of charge on it, but no potential difference between the two. So what we used to say in my electrical stuff is that capacitors resist a change in voltage. Their basic function is to resist a change in voltage. Because like I said, I can put charge on both plates of a capacitor and have no potential differential between the plates, and it will do nothing. I could put a bunch of charge on one side of the capacitor, and that would then have a potential difference between two plates, and then it would do something. So I don't like to say it just stores charge or stores energy, because there has to be the potential difference, and there has to be a mismatch between the two plates for it to be useful work or energy, or for be useful energy that you can do anything with. Yeah, they resist a change in voltage. And so now if I say, what's an inductor do? What would you think for an inductor? Now, an inductor is a coil of wire. May or may not have a internal slug or core, based on what terminology you're using. But, an inductor has a job as well in a circuit. And I just want to know what you think that is, or what you would call it. Okay, Will Morgan says inertia for current. Okay, and the other one's inertia for voltage. That's an interesting way of thinking about it. I don't know if I like the term inertia in that regard, but I see what you're saying. Yeah, so current, right? So an inductor would resist change in current, right? And that's either direction. And so I guess with inertia, you're saying, something in motion tends to stay in motion, or something in rest tends to stay at rest. So if I have a steady state current, it wants to stay at that rate, and if I got to change it, the inductor's going to oppose that. If I have no current and I try and change it, the inductor's going to oppose that as well. So I can see what you mean by inertia. I just don't like that term in that one. But maybe, sure. Maybe more for the inductor than the capacitor. Inertia and voltage, I think is what you said earlier too. I'm not sure I love that one, but definitely resisting changes in voltage. So yeah, okay. So how does that work? EE by trade, so sort of cheating here. Sure. Yeah, and as I said, your inertia term, I kind of see where you would get that, or whoever told you that would use that, but I just don't like it too. My degree is in physics, and I did a bunch of electrical theory teaching and things like that. So, yeah, PID controller for electrical, sure. Yeah, I mean, we do that with. It works for the Met guys I work with. Yeah, okay, I get it. So how does a capacitor really work? Well, we're talking about charge, and in the case of that, you can talk about holes or electrons, positive or negative, however you want to look at it. But we're talking about electrons. Electrons are easier to think about versus holes. So hole flow versus electron flow. The hole is basically the opposite of the electron. Even though proton is charged opposite of that, the hole is the void that the electron leaves or travels to, I guess is one way you could look at that. It could be the spot in the valence shell of an atom that's missing its electron, or the electron got ripped out of and left a hole there. It's where the electrons want to go to, essentially. So some guys call them hole flow versus electron flow and all that. But electrons are easier to think about because they're just little charged particles that actually exist and go places. So I prefer to think about it that way. And as you may know, you guys will obviously know, and you may know, the electrons are negatively charged. Hello. What's up? Okay. 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 Uh-huh. Oh, nice. Well, that's good news. I appreciate it. Appreciate you. Yeah, I appreciate it. Thank you. I'm currently... Well, I'm glad that the status of your side-by-side dictates the goodness of my day. No, I'm glad that you said that you think it does. You said trying to bring it together for you. It sounded like you said you. Oh, gotcha. I thought you were saying that your side-by-side came together for me, and you hope that... I was like, oh yeah, totally, man. Your side-by-side made my day. Yeah. I'm actually on the dyno right now, tuning a car. I'm doing a live stream talking about electron flow, so I can't chat. All right, dude. Michael Cody. All right, bud. Thanks, bye. So charged, electrons are negatively charged, right? So if I was to say, have a bunch of electrons in my hands, they're not going to want to stay in my hand. They're going to try and get the hell off of it. Now, unfortunately, for those guys, in this case, my hand is made of an insulator, say Delrin or rubber. Well, those little bastards are stuck where they're at. They're not going to get the option of moving around. But if my hand was made of something metal, they would move to the far ends of it. They would try and get away from each other, and they would slide across the surface of it. So if I had like a ball, say a steel sphere, whatever, a ball bearing, and I put 5 electrons on it, those 5 electrons would be easy to find. They'd be at the outside edge of that ball, and they'd be evenly spaced out from each other because they'd all repel. They'd all try and get away from each other as equidistant as possible until the minimum available felt field force of each one was there. So I'd have 5 little electrons spaced out on this sphere, perfectly spaced out. And wires are the same way. Electrons on a wire, they want to get away from each other. They don't want to hang out and be really close. I gotta keep doing this. Yes, it's 42 degrees outside. We're fucking way at the dew point, and that's our elevation. Thank you very much. And they also don't want to hang out with each other, so they're going to be pushed out to the outside of the wire. So you can see a bunch of electrons on the surface of the wire. And that's why you hear people talk about, oh, electrons travel on the surface of the wire. Now, one thing a lot of people don't know, however, is that the electrons do not carry the energy that operates your load. That is something most people do not understand. An electron, at the beginning of the circuit, leaving one plate, going through the motor or generator, whatever it happens to go through, I should say generator, we'll say motor, and then getting back to the other plate, again this is a DC circuit, have the exact same energy levels at both ends. And if they have the same energy levels, then how could they have possibly transferred the energy to load? And what turns out is that the energy that powers your load does not flow on the wires. It actually travels on the magnetic field outside of the wires, created by the electrons moving. And the energy travels on both leads evenly. The positive and negative lead are both just as important, and they transfer energy from the battery down the leads to your motor, to your light, to whatever it is. And that happens in the magnetic field. I'm going to say magnetic field, but it's a bunch of, there's different fields, E fields, V fields, a bunch of shit associated with that. But they travel on the fields outside the wire to your load. Now Tesla knew this, and that's why a lot of the shit he did seems so fantastical, with light bulbs in the ground or whatever, things that people talk about. They're like, wow, how did he have that? There's no wires. Well, it's because there doesn't have to be wires. There just has to be fields. So the electron current flow through a wire, it is not the current to power the load. It is the current to create a magnetic field strong enough to power the load. And that's something that's really hard for people to wrap their head around. But take that for a while, chew on that, and it's really actually very interesting. It explains why an electron traveling at 42-ish, 43 meters per second in a circuit can somehow create a signal at the speed of light. And you think, well, how can an electron that's moving only 42 go as fast as something traveling 100,000? Huh, right? Well, it's because it's the magnetic field. And so if I have a tube, we'll say I put a bunch of tennis balls in a tube, and I push on the end of that tube, I can push that tennis ball really slow in the tube. But when I push on it, that other one moves simultaneously, barring any compression in the tennis balls or whatever. But when I push it, that signal of me moving my finger is seen at the other side at the speed of light, at the observable rate that you can see it at the speed of light. Because I push on it, all of that stuff is in unison, moves together. It's traveling slow, but I get a signal at the speed of light. Very interesting. And so circuits are the same way. Electrons start to flow. They travel slowly, but they're all flowing simultaneously. And that signal, therefore, it travels at the speed of light along those magnetic fields on the around the wires and stuff. All right, I think I've got this thing traveling enough. I'm gonna do a couple tip ins and see how angry it gets. My trims right now are 0, which is great. Oh, that was good. That was good. Okay, I like that. All right. So at 2,000 RPM, if I tip in, I'm not getting any hesitations. That was a full throttle one, no hesitation. All right, I dig that. All right. All right, let's, why is my A-desk over here? Come on, get on my face. All right, let's do another pull. Yeah, something is not right. Something is not right. This VE curve is very typical. In fact, we're actually reaching the atypical VE curve here, and the results of the air fuel curve are not matching at fucking all. I pulled a ton of fuel out right here, and it's still rich as balls. Which means we're really in just wall wetting territory, but it seems weird that this is happening too. This actually moved down now, which is something, but man, this really, really, really feels like resonance in the fuel rails. That's what this looks like. I wonder if he blew a hose off. My idle seems kind of high now all of a sudden. What's my idle at? Idle target's 850, currently at 1050. Yeah, okay. So we'll pull the hose off or something. Take a peek at that real quick. Lane! Oh, I called it. It does have the old dampers. Oh, wow. I called it. It does have the old dampers. I'll be damned. We gotta take the dampers out of these rails.
What's that?
This fuel pulse dampers, they gotta come out.
What are they?
The old school IAG ones.
No.
This thing will not fuel. It just keeps doing that. That's the dampers causing a bunch of problems. This lean spike and this rich spike. You pull those dampers out, it's gonna go.
Really?
Yeah, it's fucked.
What are the dampers?
They're maxing out their throw because of the boost pressure, and then they go at certain times, and based on the pulse in the rail, and so they create an uneven fuel pressure in the rail.
Do they have vacuum too?
Nope.
The 3/8 ones don't.
They do not.
Yeah, those ones don't have vacuum too.
Correct. Correct. They do not. That's why they don't work.
Oh.
That's the problem. Because the fuel pressure goes up with boost and pushes the thing open. Yeah. And then it.
So the boost pressure is supposed to equalize the top of the damper.
Right.
So that it
keeps
dampens the same as boost increases.
Right.
As fuel pressure increases.
Right. It keeps the disc in the center of the stroke basically. So it provides damping action instead of getting pushed to the top to the end. So this is I'm streaming right now, right? And I said, man, this thing must have the IAG dampers in it because it's behaving like the IAG dampers. And then I pop out and show
How did
them
we
out.
not see that before?
I don't know. I think I just installed them before the tune.
Hmm?
I just installed them before the tune. I snuck in there and jammed them fuckers in there.
That's what I thought.
Just to prove a point.
That's what I thought. No, I'm just curious to
Yeah.
our final, or maybe they were fucking stuck or something. And they
Well,
weren't
no,
working.
before he was on break-in, right? I never really did a full tune on it and all that, but it's very problematic right now. That's for sure. Yeah. But will they fit in that rail? I don't know if they will.
That's why.
Right, they don't.
Trust the post.
Yeah,
That's why I have a set of three.
because we bought them for it and they didn't fit.
Yeah, that's exactly. That is why.
I can't.
Gotta do
I-
radium rails or something.
You gotta do, or just put plugs in them. The plugs would be better than this. This fueling's bad. It's bad.
That's what I was reading your notes on this one.
Which one's that?
This car, Leeson Baker, you tweeted back in September and you noted that he has a fuel pressure issue and a boost control issue.
Uh huh.
But I just drove it from there to here and it drives like shit, so. Or you just sent me a graph of the AC car. We noted it back in September that he needs to bring the car back when he has time to let us die because it has a fuel pressure issue or a boost control issue. So. He should have been having us do that the whole time it was here because we could have figured that out.
Well, he didn't mention anything about it, but I didn't notice anything on the drive.
Don's maps the car has a fueling issue and a boost control issue at a 16 psi at 0% base KDB cycle versus the 9 psi that it should. It reads 255 grams of air, making it run very rich. Cleaning map made no change. Boost control line sounds okay, but potentially the solenoid is bad.
Alrighty. I'm back. Oh fuck! What time is it? Oh, it's 4:20. I've got time to do all this shit. Boy, my VE curve is gonna be totally screwed now. I think in the literal sense, tennis ball example would be that the speed of sound through the tennis balls, it accounts for compression of the material or electromagnetic field if you have speed of light for a signal though. I think the literal tennis ball example. Yeah, I said discounting compression for that reason, but you know, if the tennis ball was probably a bad example, I could have said steel balls or something in the tube. The point was that when I start pushing, everything moves, and the rate at which we can observe that movement. You know, from if I was to time it from when I pushed it to when you could see it, or if you were to have a stopwatch and from push to movement at the other end, it'd be the speed of light. What's up?
So now that it has adequate stable fuel pressure, maybe it was dropping PSI so much that the dampers were still working. It wasn't holding them at top,
Oh, maybe.
right? But
Yeah.
now it's
Yeah, the fuel pressure's rock steady. Yeah, that could be. Or I thought what was dropping really bad was actually also the dampers, too, causing the lean spike. Yeah, of course. But the pressure is now rock steady. It's like 45 across the whole thing.
So that means my shit worked.
That means your shit worked. Yep. Let's see. Let me look at that. Make sure I'm not lying to you. Last time I looked at it, it was steady. Let's see. This last pull here. Oh shit! Look at that. It dropped a ton. I'm just kidding. 43.4 at the beginning of the pull. 44.4 at the end of the pull.
Sweet.
So it went up a pound. You fucked it all up, dude.
I did.
You fucked it
Not
up.
steady.
It's not steady. It's it moved a whole pound.
Well,
Yeah.
If we take a snapshot, if we put 40 at the bottom and 42 at the top, it would be like this.
Yeah, that's right. Yep. If our axes, if we have 42 as the low and 40, or 40 is the low and 42 is the high, it looked like almost a straight line up.
Straight up and down.
Yeah, that's a huge difference. I have that sometimes in Link because it'll auto scale on some parameters, and I'll do a pull and I'll look at something, like like airfield trim, and it's like, I'm like, holy shit! And I look and it says 0.1, 0.2, it's scaled out. It was actually perfect, but because it went such a small scale, it just looked like it was all over the place.
I mean, people do that with their dynos too.
Oh yeah, lots of guys do that with dynos for sure.
Smoothing on. Look how flat that graph is.
Yeah, I wish this dyno doesn't have smoothing. It just doesn't have that.
Good. They shouldn't.
No, I agree. And when things are bad, boy, it shows.
Mm-hmm.
But it looks really smooth now.
I mean,
But
that FA torque dip that they all talk about is fucking
gnarly.
It's like
Yeah, you see it big time.
it's like a flat down and then an arc back up.
Yeah. So what do you want? How do you want to fix this?
It's probably gonna need rails
Or plugs?
or plug.
I mean, you should have 3 empty plugs, right?
Most likely,
Yeah. It's just not easy to get to because it's on the bottom.
because this kit sucks.
Yeah. And it's full of fuel. Yeah. Well, lucky for you guys.
Something I can do in the morning.
Yeah, I mean, I didn't plan on coming in tomorrow because I got shit to do, but I got information my delivery is in the morning at around 10:30ish.
Okay, I should be able to have
So,
it wrapped up by then.
well, no, I won't be here until like 1 or something
No.
because I still have things to do.
Just for your reference.
Yeah, or I can come in earlier and do it Thursday while you're working on Ron King's car, and then finish this and then do
Am I
his
working on
after.
Ron King's car?
It should be.
So I saw it on your schedule, but I didn't see it on my end.
He said he talked to Chase and Chase confirmed with him, but it's not on there.
Nope. I was meant to ask you about that. So
I spoke with Chase. Chase confirmed Thursday is a go.
perfect.
Do you remember what you're doing with it?
Nope.
This is about as typical as it gets.
I just saw Ron King on Tuesday, and I was like, okay. It's just the same thing as when I saw Jim on Tuesday. I was like, whoa, hold on. What are you talking about? He needs this and this and this and this and this, and I have a full week of scheduling.
So do you guys even have a Cobb SF intake for him?
No.
Fuck. Better overnight the shit out of that bitch.
I mean, if I do it right, well, I mean, it's past 4 o'clock, so it doesn't even matter now.
They still have to overnight it though, so it's here. Oh wait, yeah, day after tomorrow, because his stuff is Thursday and today's Tuesday, right? Yeah.
Matt's car.
GD obviously GD
Lithium
thing.
plugs.
Yeah, I do lithiums for sure. Yeah,
Factory flow packs is all good.
it should be. Yeah,
We're on a 35.9 hundo now.
fun. Well, you're not
Well, not right this minute.
because you don't have it.
I have one.
I'm taking mine back.
Yeah, we have a new one.
Oh, you guys got one?
Mm-hmm.
Okay, with the right housing on it and everything.
Yep. We got one in.
Okay.
Yeah, yours is in my box. I'll grab it. Oh, jeez.
And so what else? We're doing the intake, and what else? We're doing something else with this car too, right?
Oh, I don't know. That's what I meant to ask you this morning, but it's been crazy. What's up?
Was there anything else we had to know on actual car?
I don't think so, unless you saw anything.
Boot, seal, lug nuts.
Okay, that works for me. That's all the things that I saw. So
No, just intake. That's it. Yeah. I like my history. So just the intake.
so intake and tube.
Yeah, I
Post
mean,
snap tube in.
yeah, whatever it takes to make it fit with his front mount.
Mm-hmm.
So I can go hybrid with it, do MAF down low, and then go speed density up top.
Yeah. Pretty much.
What fuel rails does he have on that kit, on that car? Did you guys do it?
Nope.
Do you know what they are?
Probably Perrin or some shit.
Hey, Elaine, did
Yes,
you
sir.
tell Deuce he didn't know anything?
Yes.
Okay. Carson had MSA typed up, and I went to fill him out. He was like, Lane told me I didn't have to pay anything. I was like, oh.
What did he have on there?
Carson had an hour and a half of labor for diagging and setting up the steering wheel, but
Oh, okay. I mean, I looked at it for 10
it's
minutes.
Deuce.
so-
I'm not worried about it, but I just wanted to check with that before. I was just like, oh, sure.
No, I spent like 10 minutes on it, so.
Okay.
Let's see.
Why not check?
Nope.
Finish making field. You have the speed of light. Single though. All good. It works. Just being particular. Reading NGK site, it seems like the ruthenium plugs are pretty good for ignitability. How does the heat range factor into things?
Okay. So, on this, would you want rails with dampers on it?
I don't give a shit.
Okay. So, no dampers in those.
Just put plugs in it.
Happy days.
Yeah. Put plugs in it so that we can get in this car and get it done.
Yep.
You know, and the long term, next time we want to do an upgrade, then we do that. But I don't think it's gonna happen.
Yeah, no.
So.
I mean, if I told him the fuel rails are leaking, we'd get it done tomorrow.
You're funny.
Not that there was a performance or reliability thing, but just
Right.
You know,
I get it.
leaking.
Yeah, I get it. All right.
I should show him the fucking ECS charge pipe is leaking too.
This thing is laggy as shit. This is not how fast these cars are.
No.
These turbos. No, our kit, man, works.
It works really good.
And your front mountain's wonderful.
It works great.
So, yeah, our turbo kit works great.
No, because
And
this is exactly Mattel's car, except for it's a 770 instead of a 660. It's the same short block. It's the same heads.
same cams.
Same
Yeah, it just has our turbo kit
Mm-hmm.
and intercooler kit.
Mm-hmm. But it has an ETS instead of a parent front mount, which is even bigger.
What does?
Mattel's has a 3.5 inch.
He has the
ETS,
core,
Yeah.
but with your piping.
with my pipe.
Right. Yeah.
Yeah. And this one has the 2-inch parent one or whatever, you know, the
Yeah.
standard thing.
3-inch, yeah.
One,
Mm-hmm. Yeah, but I mean, it's obvious. Like it just does not spool as fast.
Oh, 5,000.
Yeah.
Which Aaron's is a 2.3 and it's less than that.
Right. Yeah. That's what I was saying on the stream, was that our setup on the 2.3 with my cams and your intercooler and and our turbo kit fucking spools faster.
Yeah.
Dramatically faster than this thing.
Lane, do we have a Cobb SF in for GD?
We do not.
Okay. I'm glad you texted about Ron.
Okay.
No, Ron was annoying because he didn't deposit anything and like didn't actually go through any of the normal processes. But I'm glad that you said that because I'd rather just buy one and have it on the shelf in case he doesn't buy it than.
Well, he's getting retuned on Thursday. I meant to ask that about it this
I'm
morning
gonna,
and I got
I'm gonna
distracted.
overnight one right now so that way it's here. But
Okay.
John saved us on that one.
Yeah, I was gonna and I completely forgot.
Happens.
So. No, yeah, that's but. And it comes on super hard too.
Yeah, it's not even that.
It's late and hard.
It's late. Yeah. Yeah.
Whereas the other one's like softer as it comes in.
Yeah. Yeah. And then the fucking fuel's everywhere. I mean, it might help a little bit not having so much richness right there, but
You know what?
What?
Another thing too. This has the ET ETS style downpipe too. So tight 90.
Oh,
off
the
back
pinched
of
off back of the turbo. Yeah, was the exact reason why I said I want the turbo down low.
Yeah.
Yeah.
Yeah, I use about 2/3 of a long radius 90 in 3-inch. So it's more like this
Yeah.
versus this.
Yeah.
And this is ETS.
Yeah, ETS, especially on their GR kit.
Oh god,
That thing is way cheated too. Yeah, I hate it.
it's super bad.
So
Yeah, they straight up take a 90 and cut it like almost level with the inner wall.
yeah.
Like it's bad.
I don't know how they get the pipe around again after they do that. They must just expand it or something.
Goober welded.
Is it?
Mm-hmm.
Oh, okay.
Yeah.
Yeah, I don't like their turbo location at all.
Nope.
No, it sucks.
But it's hot boy, so people. Will
But it's
fucking
up
pay
top,
$4
so everyone's
for
like,
it.
I want to look at the turbo. Everyone I was showing the our kit to is like, dude, that's so sexy.
Yeah.
People
Everyone
love it.
loves it.
Yeah.
Everyone fucking.
It's not way up top.
Nope.
It's fucking like stealthy.
And people
It
ask
looks
me like,
compact.
Does it cook this? Does it cook that? I'm like, nope.
No, it's in a good spot.
Is what it was meant to do. Was
Yeah.
to not cook these things. That was the main thing is efficiency, and number 2 was make it fit in the car.
Well, we pulled like 16 inches of downpipe out of it.
Yeah. And about
in 80 degrees.
Yeah, and about an inch of up pipe.
Yeah.
And I would assume 6 to 10 inches of charge pipe, roughly. So.
Oh, yeah, at least.
Yeah.
Yeah.
I reiterated on Mason Baker's invoice that per his access port and per his notes, we tuned his car back in September. He still needs to get his fuel issue and stuff done. So that way when his shit inevitably blows up in 2 months and he tries to blame us for the 2, we can be like, hey.
I've been trying to tell you to get it fixed.
Yeah.
I know what you want.
Yeah, so he's got now 2 invoices with a note and it's also on the access port map. So.
Perfect.
That's why I put it there before. Some people have a hard time listening. I'm sure this ding has been really annoying for you guys. Okay, so for heat range, how does heat range a factor into things? Heat range is important. You have two key factors associated with heat range, and they're both. Go ahead. What's up?
Good question. I put a new O2 sensor in Mike's car. Doesn't boom.
This guy?
Yep. Mike's gas cans?
Yeah.
So the new O2 works now?
Yes.
Good.
We're trying with that.
No, it made a lot of progress on it.
Oh, it sounds great.
Yeah, throttle body was dicked up and the O2 sensor was dicked up.
Yes.
So got those done and did a bunch of adjustments to it, and it drove great for me and idled great. Yeah. Yeah, no problem.
We might have to dump some fuel out of that one.
I don't know if it had like a chipped tooth on the throttle body or what, but that does happen sometimes. Yeah, it's really weird. So with heat range, right? The spark plug is in the chamber, and in the chamber we have post-combustion products, right? We have byproducts of combustion, often involving carbon, as well as small bits of oil that we burn off, additives that are put in the fuel and all that. And that stuff plates out. And carbon and all that stuff will start to stick to things inside the cylinder. You get carbon on a spark plug, and then you just short it to ground, and it no longer runs. So the spark plug has to be hot enough to clean itself. That's the key, right? The heat range is about cleaning it. If you look at two spark plugs, there are two different heat ranges. You can tell which one's the hotter plug, because the ceramic on it connects to the body of the plug much further away from the electrode on a hotter plug than on a colder plug. I've had plugs so cold the ceramic is about this long, and it connects to the body of the plug. And then on higher heat range plugs, the ceramic is like this long before it connects to the body of the plug. And what we're doing is we're hanging this piece of metal out in space, supporting it with ceramic non-conductive material, and letting it get hot. That's what we're doing. We're letting it get hot out there. And then the closer that we bring it to, or the sooner we bring it in contact with the body of the plug, which is in contact with the head, the sooner that gets cooled down, or the more it gets cooled down, I should say. The less heat temperature delta we have on that piece of metal dangling out there in the chamber. So the first thing is that it has to be hot enough to clean. It has to get hot enough to self-clean. And that's why if you fire a race car up that has race car plugs in it that are usually like, heat range 5 or something, and you move it like 2 or 3 times, your plugs are fouled, you're screwed. If you don't let it warm up, you don't put some load on it, the plugs won't get hot enough to clean, and they'll get fouled, and you won't be able to recover them, and you got to change the plugs again. So self-cleaning is number one. And And the idea is that we want to make sure that whatever heat range it is enough that they get clean. Now, in a race environment, as long as the race happens, even really cold plugs will clean. Because there's a really high duty cycle, lots of combustion events, lots of heat, lots of BTUs being released by repeated high energy combustion events. It's going to heat up that little dangly piece of metal in the cylinder, right? And it's going to get glowing red hot and it's going to burn the carbon off of it. Same for the insulator. The ceramic is going to get hot and burn the carbon and other shit off of it. And that's why plugs look the way they do. A lean plug, right? It's lean, is white. Well, it's white because it's really goddamn clean because it got really goddamn hot. Okay? So, first thing, it's got to clean. The hotter the better for cleaning. With the exception of, once you get too hot, you start to melt the electrode. So you don't want to melt stuff. But that range is pretty wide. You can go pretty hot before you start to melt things. But if you're melting the electrode, that means that your constant heat load is higher than the material and electrode can handle. That's why iridium and ruthenium came about, because those materials handle more heat before they melt. That's the idea behind those. So that's great. I have a plug that gets hot and it cleans itself. Well, what happens when I have a cylinder that's already retained a bunch of heat and I have fuel that is relatively low octane for the amount of load that it's carrying? Well, now I have this really hot spot in the middle of the cylinder. Now, detonation is typically, or is, a secondary combustion event that is ignited somewhere in the cylinder near peak cylinder pressure. So typically 20 degrees or so after top dead center. So if I got a really hot spark plug, I'm not creating a secondary ignition event because that ignition event is still happening at the same spot. But what I could create is a pre-ignition event. I can get it hot enough that now the fuel and air ignite as the piston is traveling up and the pressure is increasing, and have enough residual heat there. I create a pre-ignition event. And so that's the concern with that. A lot of guys go, oh, go to cold plug, reduce a knock. I'm like, how? Like, what is it going to do? You're going to have it ignite twice? Like, that's not what knock is. Knock happens after the initial combustion event begins. It happens because we've added enough energy, and in the form of both heat and pressure, to ignite the other molecules somewhere in the cylinder based on wherever that localized area is. And all we're doing is, if you took a reactants and products energy state graph, if you've ever seen those, it looks, kind of like this dyno graph, really. Only there's a step missing out of this. I wonder if I can draw this and show you guys. What's a good way of doing this? Let me just do this. Let me go. Products, reactants, energy, graph. Images. Okay. Here we go. Perfect. This is perfect. Will this work? What happened? It stopped. Okay, there we go. I like that one, but I think I like this other one more. I'm going to show it to you in a second. Delta G. Here we go. This is what I want to get. Alright, so how do I do this? Okay, so I'm going to go here. Let me go into my shock dyno, image, runtimes, chat, Android, Cobb, link, iPhone, Mtron. I don't see Chrome, so I add Chrome. Window capture. Chrome. Alright, here's Chrome.
When you're done, I got another question for you.
Yep. Okay, so let's look at this. Oopsie, I don't want to do that. I kind of do, but I want to do this. Like that. And then I want to do this. And zoop. And then zoop. There we go. That's what I want. All right, so look right here. We got reactants, right? In this case, it's going to be our fuel and our air charge. Essentially, it's going to be our reactants. Okay, and they're going to have an energy state. And so this line shows the energy state of those reactants. Now, there is something to realize that, one of them is going to be warmer than the other, cooler than the other, whatever. But there's like, a cumulative energy state is here. Now, if you just take fuel and air and you mix it together and just pour it on the ground, mix it in your hands, throw your hands around or whatever, it's not going to just burst into flames, right? It takes an energy source to get those reactants to react, right? Before they start, you have to do something to make them burn. And that's what we're seeing here. So we're seeing here, here's this is called energy barrier on this part, but it's the activation energy. And here's it's right here. See, energy A, energy activation. How much energy I got to put in here, right, to start this reaction? Well, this energy can be thermal. It can be, it's more often going to be thermal. But pressure is part of that. As you raise cylinder pressure, we're adding energy to it, which could be considered thermal, because usually as you compress things, they heat up. So I have that, and I have flame happening in the chamber. So I have heat being added to the chamber, I got pressure being added to the chamber. And if I have my cylinder head, let's say you got one hot spot in it somewhere in it, now I have an area, we'll say that before the pressure happens, I have this I'm really close to the activation energy on my head, right up here. I'm really close. I haven't activated it yet. But then as the pressure goes up in this cylinder, it heats up a little more, it just tips the scale, boom, and the reaction starts to happen. And so that little spot on the head that had high energy, had extra heat, and then the combination of that and the pressure, boom, puts us over the edge, and we start a reaction, and our combustion starts to happen. Well, this same thing happens with the spark plug. We have all this stuff in there. We're squeezing it, and then we add a spark, and that knocks us over the edge, and then boom, we initiate a reaction, okay? So it may not be squeezed out. The pressure could just be this a little bit, really. Honestly, the pressure is probably pretty low, because it takes more to blow it up than just more energy from the spark than the pressure. But the point is that pressure gives us a portion of the energy needed for this reaction to happen. And in subsequent reactions, that energy in the cylinder also provides us, the pressure in the cylinder gives us energy towards further reactions. And what's important about this is the proximity of the molecules to each other has another huge effect on burn speed, which I talked about earlier, burn speed. And this is where I wanted to go with it, with burn speed, was this. If I go into space and I don't have an air conditioning suit on, I will overheat. I'm not going to freeze. I'm going to overheat. My body is producing heat continuously, and there's no molecules out there to take the heat from my body. I'm going to overheat. Those astronauts, they have cooling suits in there. They have temperature control modules in those suits that they have. Because there isn't any air when they go on the spacewalk. There's no air around them. There's no molecules around them. There's not, I want to say no molecules. There's insufficient molecules around them to draw the heat off of their body that they're creating. They're going to overheat. If I go in my cylinder and I have two molecules in there, and I say two molecules. We'll say I have four molecules. A fuel, an oxygen, a fuel, and an oxygen, two of each. And I put them really far apart. And I managed to get one of them to light up. And it's really far from the other one. The amount of heat that's able to make it from this one to the next one is very, 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 very low because they're so far apart. There's this void between them. There's no material there. There's no mass. There's no molecules. There's nothing between them to transfer the heat from one to the other. And it's too far apart to do it on its own. Luckily, we don't have that problem. When we put air and fuel in the cylinder, there's a bunch of it. And then we compress it, and we push them close together. That's what we're doing. We're taking those molecules that are far apart that might not even do anything otherwise, and we push them close together, get them in close proximity to each other, and then we ignite them by spark event, right? We go over our activation energy here with the spark event, and we start that combustion at the flame kernel, which I just talked about earlier, at that flame kernel. And now the rest of the molecules are close enough that the energy being released by those initial molecules burning is enough that they are able to absorb that energy and ignite themselves. The closer they are together, the better that heat transfer is. However, the closer they are together, the more of them there is. And the more of them there is, the more molecules you have to absorb energy. And in this way, you can actually quench a reaction. too many molecules and without enough activation energy, and you will maybe get one to go, and it can't. The energy that's released by that one molecule, say one little pair, go. If there's too many around them that share or absorb what's around them, then you can actually quench yourself out. Or if you have too many materials that, like say water, you have water injection in there, and the water is going to absorb a ton of heat. And if there's too much water in there, it's going to absorb the heat and not allow that energy to transfer from one molecule to the next. It's not going to allow enough energy transfer to the next one to propagate the flame front or the burn. So you can quench with too much material in the cylinders. That's important to know. So one way of doing that is with a teeny tiny gap. If you got a teeny tiny gap and you're in a super, super dense environment with stuff like water and steam or whatever you have in there, it's possible that even though you have enough energy to light off a few, that you quench the whole combustion event out. It doesn't happen. It's not very easy to happen with just fuel. It's really easy to happen with water injection. But you can quench out your burn. It is possible. But anyways, the point is that is that the energy in there has to be able to transfer from the one set of burning molecules to the next one, right? It has to be able to propagate in the cylinder. And it does that by giving enough energy that it breaks over this activation energy that the next one can ignite. So if I have a larger gap, then like I discussed earlier, I need more energy to cross that gap. And if I pack a bunch of molecules in between there, I need even more energy to ionize all the molecules in that little chain. And the other thing, too, is that when molecules are moving past two electrodes, it's more difficult to ionize them because they're moving, and you're getting like fresh ones in the way. So the more turbulent the cylinder is, and the more horsepower you have, and the more overlap flow, the more turbulence you have in there, the more spark energy you need because all that shit's moving around a bunch. Anecdotal, real life anecdote for that is in breakers when we have really large power distribution breakers like 4160, 15 kilovolt, 34,000 kilovolts, 115,000 kilovolts, big power breakers that they use for distribution in plants and stuff. In the breakers where they have all the contacts, when they open the contacts, okay, there's an arc that's formed. I mean, we're looking at the definition of arc welding. You strike an arc by taking two metals and putting them in contact with each other, or getting it close enough that it's able to arc across there and start melting the metal. Well, here I have, a lot of energy traveling through two contacts in this gigantic breaker, and I go, and I pull it apart, right? There's going to be an arc. And so giant breakers have a bunch of things built into them to quench that arc. They have what's called arc chutes, a bunch of layers of melamine that are really close to the really close to the contacts. They just hug the outside contour of the contacts to prevent an arc from traveling around or out, around. So it gives it less pathway for the arc to travel. And then they have buffers where they blow air. They actually physically have just a big cylinder attached to the lever arm of these contacts. And so when the contacts open up, it compresses the cylinder, and they route that air and they blow it at the contacts, because moving air is harder to ionize than stationary air. So it blows on the contacts. And the same thing happens in the cylinder. If I got too much movement in there, and there's not enough density, and there's not enough spark energy, I can have misfire. I can not take that activation energy from the energy of the combustion and transfer to the next one, or I may not even be able to get it to the point where I can ionize the molecules between the two electrodes on my spark plug, because there's just too much movement there, too much going on, that per unit time I end up having to need way more spark energy than I currently have. What am I trying to say? So the burn speed is affected by the proximity of the molecules. The closer they are, the more likely they are to transmit their power, exchange power energy to the neighboring molecules and exceed the activation energy and propagate the burn in the cylinder. And you see that. You see that in your ignition advance tables, right? When I am at cruise, all the molecules are really far apart. I got to light this thing off at 35, 50, 60 degrees before top dead center because it's got to burn and then needs time to get the energy transfer to the next one, energy time transfer to the next one, right? It takes a long time to get that stuff, the energy going to the neighboring molecules. And so I have this really advanced ignition curve. When I'm at a high load, everything's packed in there really close, and I light that thing off. Well, the energy transfer is easy. It just goes from one to the other. They're right next to each other, right? And that exponential gain that we talked about earlier, it happens a lot faster. The surface area of that flame kernel grows quicker, and then that energy is now in contact with more molecules faster than when the molecules are all really spread apart. So the amount of, or the proximity of the molecules greatly affects the burn speed, especially if the reactant has its own oxygen on board. So with ethanol, we got a little bit of oxygen in there, and then we have to, which changes our stoichiometric ratio, which is why it's 9 to 1 instead of 14.7 like gasoline. And then I pack a bunch of them in there and I light it off. Well, shit, they are really, really quick to burn, share energy, and go through the cylinder. So we get a burn speed of 20-something meters per second versus like 18 or whatever it is for gasoline, right? You get a much faster burn speed with the higher density, oxygen carrying, packed in the cylinder fuel than you would with something that was lower density and spread out more. That doesn't have an oxygen. So, how does that all affect our heat range? Well, we need it to be hot enough to clean, but we need to be cold enough that we're not causing pre-ignition events, or we're not retaining a bunch of heat in the cylinder, and cold enough that we don't melt the electrodes. So I guess three things: don't melt the electrode on the end of the plug. So that's how it plays in. That was a long explanation, wasn't it? The same paper I read also talked about using EGR to help the burn. Yeah, so EGR to help the burn is a lot about warming those reactants. If I warm those reactants and I raise their energy state and I distribute them better in the cylinder, then I help them ignite. But I don't increase the burn speed because I still have a bunch of non-conductive and non-flammable materials in between all of them. So it helps a lot with atomization and homogeneous distribution of the charge in the cylinder more than anything, because overall it still slows the reaction. It still slows the burn down by having exhaust in there. But when you have so little reactants going in there and you're at a low engine speed and you're at a low heat load, and all of that, you need anything you can, and a low flow rate. That's another key too, right? When the airflow is slow in there, tumble is less, swirl is less, the mixture rate is just not there. So adding the EGR helps to preheat the stuff, but also increase the velocity. If I add a bunch of exhaust gas in there, right, that's non-combustible. That's not affecting my air-fuel ratio. It doesn't do anything to it. But what it does do is add more material being drawn into the cylinder, raises our port velocity, increases our tumble and swirl, adds energy to the reactants, brings them closer, and makes a more homogenized mixture in the cylinder. So when we go to light it, it burns more consistently. And that's really the big thing. It burns consistently and more even and more thoroughly. That's really the big gains you get from EGR. And I'm sure your paper probably said the same stuff. All right, it is 5 o'clock, which means it is quitting time. I got to stop this. The guys are going to work on this tomorrow, and then I'll do some personal stuff in the morning, and I'll probably come back and finish this tune. And I think it'll be interesting, as long as I don't move the car, to see the AFR traces immediately after he plugs the rails and takes out those old-style dampers. So for my super low temp and short-running time environment, I want to plug. That's correct. Yep. If you're fouling plugs, they're not cleaning. If they're not cleaning, it's too cold. Yeah. And even cars like Subarus come with like 7s and 8s from the factory. I'm sorry, that's not correct. They come with 5s and 6s from the factory. 5s and 6s are hot. They're way hotter than 7s and 8s. So 5s and 6s from the factory are hotter, and they're made for cars like ours that spend a lot of time idling, right? It's got to be able to clean when it's idle, because if you just idle it and it fouls up, that's no good. So they're pretty warm for that. And the car makes 20 to 30 horsepower continuously when driving on the highway. And so it can't be so hot that it melts it in that environment. But if you go racing on a hot plug, you're going to melt the electrodes on it. We've all seen it. We've seen them melt. If you don't have pre-ignition, you're lucky you don't have that. There's no damage being done. So you can't have a plug that's too hot. For ethanol, because there's so much material being put in the cylinder, and it's got a big cooling effect, the higher, hotter plug helps to do one thing I forgot to mention earlier, is it helps to create localized atomization of the air-fuel charge. It's not setting it off, but the stuff that hits the plug and gets around the plug is more likely to vaporize and be more homogenized and be at a higher energy state just from the heat of the plug before the ignition event happens. So the hotter plug helps to keep that area from being too being covered in liquid, essentially, I guess the best way to say it, right? You get a more, I just lost something, that's weird. You get a more homogenized mixture. My computer says something came unplugged, I don't know what it was. I probably went into fucking sleep mode, didn't I? No, that's paused. Okay. What's going on? This guy? Identical plug to the one I'm looking at with a slanted ground electrode. Electrode shape is mostly or typically engine dependent as to what it's going to want, and to which direction you're trying to push the flame kernel, where you're trying to start that propagation event. Because when you start that, you saw electrodes in the way, and so like if I show the plug as if it's like this, right? But really it's in the cylinder like this, right? So when I start burning fuel, it's shielded by the ground strap. That electrode shields the kernel, so it's going to start burning in this direction, and it's going to go out and then up, right? Some chambers, though, are set up in a way where they pull that electrode down so that flame kernel goes up into the chamber. Well, I say up in the chamber, everything down into the chamber towards the piston. So how that strap is located depends on what kind of combustion you're going for. What are you trying to make happen with it? And how is the engine designed? Does it have a big dish right below it, and you're trying to have that flame kernel and the burn down towards the piston as much as out? Or does out work better before it starts happening? A big flat top piston with a big dome on it, down's not going to do you any good, because the piston's only going to move like 15, 20 thousandths by 20 degrees up to the center anyways, right? So that's the shape of the chamber that you're working with. But if you got a big dish below it, you can go down, right? So where that electrode is will kind of dictate what direction your flame front is going to travel in the cylinder. All right, that's it. So I got to go. Have yourselves a good